The correct and efficient operation of the engine depends on the correct amount of injected fuel. The fuel supply system consists of several elements that participate in the delivery of gasoline for injection. All elements in the fuel supply system must function correctly and be coordinated with each other. The tank is an element that stores fuel, and the pump pushes it through the system to the injectors that inject at the mixture's formation point. In the previous lesson, the fuel supply system's tasks and the tank's role were described, and in this lesson, you will get to know the fuel pump. Fuel pump. The task of the pump is to distribute the fuel from the tank through the system. In all engine operating modes, the pump should deliver a sufficient amount of fuel with the appropriate pressure for efficient injection. The fuel pump must meet certain requirements for the smooth operation of the injection system. Delivery volume from 60 to 250 liters per hour. Fuel system pressure from 300 to 600 kilopascal, that is 3 to 6 bar depending on the injection system. Creation of system pressure already at 50 to 60% of nominal battery voltage, decisive factor in cold engine start. The fuel pump is a DC electric motor with permanent magnets in the stator. The electric motor has a rotor with windings. Power is supplied to the rotor windings via brushes and commutator, while the stator permanent magnets are placed around the rotor. When power is applied to the rotor windings, the rotor turns. There is an impeller on the rotor shaft, which rotates and sucks fuel from the tank and pushes it under pressure into the fuel supply system. When the pump is running, the fuel flows through the pump and around the electric motor. In this way, the pump is lubricated and cooled, and the highly flammable fuel is safe from explosion because it lacks oxygen. The fuel pump can be positive displacement and flow type. The shape of the impeller defines the type of pump. Positive displacement pumps directly feed the injection system. They enable a system pressure greater than 4 bar and have a high delivery speed at low voltages. However, these pumps are noisy during operation and sensitive to the appearance of bubbles in the heated fuel. There are two types of positive displacement pump impeller, a roller cell pump and an internal gear pump. In a roller cell pump, the metal rollers float freely in the channels between the rotating and fixed parts of the impeller. When the rotor rotates, due to centrifugal force, the rollers are thrown out and close the fuel chambers. The impeller at the inlet sucks fuel from the tank and at the outlet expels the fuel under pressure, pushing it through the pump into the supply system. When the injection system has a high-pressure pump, as in direct injection and diesel systems, a flow-type pump is used. It has the task of bringing the fuel from the tank to the high-pressure pump. The impeller of the flow pump pushes the fuel with numerous vanes, creating pressure continuously without oscillations. They are quiet in operation and are not sensitive to the formation of bubbles because they can separate them through the degassing bore. However, flow-type pumps achieve a maximum pressure of 4 bar. The pump pushes the fuel into the system under a certain pressure. At the outlet of the pump, there is a non-return valve that does not allow fuel from the system to return to the tank after stopping the pump and turning off the engine. The injection system requires that there is fuel ready at idle to inject when the engine is restarted. It is the resting systemic pressure. If the fuel is returned to the tank after switching off, it is difficult to start the engine, especially when the engine is warmed up. There is a safety valve on the pump impeller that opens when there is a blockage in the fuel supply. To avoid bursting the supply hose and spilling fuel due to excessive pressure, a safety valve relieves the pressure by returning fuel to the tank. The valve opens at 7 bar. The check is done by measuring the fuel pressure at the pump outlet when we close the flow. If the pressure is maintained at 7 bar, then the safety valve is correct, and the pump is good and powerful because it can create much more pressure than necessary. The electrical connections on the pump must be clean without dirt, corrosion, and burns, with a good connection to the outlet. If there is a transient resistance, the pump receives a lower voltage and cannot deliver enough fuel to start the engine at startup. The voltage difference between the accumulator and the pump connections must not exceed 1 volt. So, we perform the check by activating the fuel pump and then measuring the voltage at the battery terminals and at the pump connection. The voltage difference should be less than 1 volt. The fuel pump can be outside or inside the tank, submerged. With older injection systems, the pump was outside the tank and often under the vehicle. Due to poor exploitation conditions, the housing rusts and it can leak. Also, electrical plugs get dirty and corrode faster. When the pump leaks, it must be replaced with a new one. In newer systems, the pump is submerged in the fuel inside the tank. If the pump leaks, it can still be used because the fuel is poured into the tank. Modern vehicles have a pump module that is inside the fuel tank. In addition to the pump, the module also contains a fuel level sensor. The module consists of a vortex bowl that provides the pump with constant access to fuel and does not depend on rocking during cornering. At the bottom, there is a valve that lets fuel from the tank into the container and prevents it from escaping. The return line returns the fuel to the vortex bowl so that the pump is supplied with the required amount of filtered fuel. At the entrance to the pump, there is a pre-filter as the first line of defense against impurities from the fuel. The filter consists of a fine mesh that prevents small particles from being drawn into the pump and sent through the system. When there is sludge in the tank, it accumulates on the pre-filter, preventing the fuel flow and making the engine difficult to run. In this case, the pump module is removed and disassembled to clean the filter. When replacing a faulty fuel pump, the pre-filter is also changed. Otherwise, manufacturers do not provide a warranty for the pump. The electronic engine control unit controls the operation of the pump via the pump relay. The power supply is provided via the fuel pump fuse and relay. When it is necessary to check the pump and fuel supply system without starting the engine, then remove the pump relay and short-circuit terminals 30 and 87 on the relay board. Thus, the pump is activated without the engine running. The pump is the key element for delivering fuel to the injectors that perform the injection and mixture formation. A correct pump is a prerequisite for proper engine operation.